Hello students, let's start chapter 16, Light. Warm up. Look at the picture and answer the questions given below. Question number 1. What is this phenomenon? Second, when does it take place? Third, how many colors are there? Let's know about how can we see things. Second, reflection of light, formation of image by a plane mirror, multiple reflections, multiple images, dispersion of light, structure of eyes, care of eyes. Visually challenged persons can read and write. What is Braille system? We have already learnt about the different phenomena related to light. Light enables us to see the different objects around us. Let us try to understand the visibility of objects. First, what makes things visible? Light is a form of energy which, when it falls on our eyes, form an object either by emission or by reflection, causes the sensation of vision in our eyes and makes the object visible. Light is that factor which makes objects visible. Luminous objects like sun, lighted candle or glowing bulb emit light which enters our eyes, and non-luminous objects like book, pen, trees, mountain, table, chair and countless objects around us, when reflects light falling on them and when the reflected light enters our eyes, then our sense of vision is enabled to see the objects. It means that eyes alone cannot see any object. It is only when light from an object enters our eyes that we see the object. The light may have been emitted by the object or may have been reflected by it. Since class 6, we have been learning about the reflection of light. Let us recall. Reflection of light. Reflection of light may be defined in the following ways. Number 1. The phenomenon in which a ray of light after falling on a smooth polished surface or mirror returns in the same medium is called reflection. The change in the direction of light when it falls on any smooth polished shining surface is called reflection of light. The phenomenon of returning back of some of the parts of light ray which falls on a smooth polished shining surface is known as reflection of light. In continuation, let us learn something more about the reflection of light. Terms used in the reflection of light. We should know about some terms used in the reflection of light. Look at this image. Terms used in the reflection of light. Incident ray. Light which falls on the surface of a reflecting material is known as incident ray. From the figure given here, PO is an incident ray. Reflected ray, light which turns back in the same medium after reflection is called reflected ray. From the figure given here, OR is the reflected ray. Point of incidence, the point at which the light ray strikes the reflecting surface is called point of incidence. Normal, the perpendicular line drawn from the point of incidence on the reflecting surface is called normal. In the figure, it is denoted by ON. Angle of incidence. The angle formed between the incident ray PO and the normal ON is the angle of incidence. In figure, it is denoted by angle I. Angle of reflection. The angle formed between the reflected ray OR and the normal ON is the angle of reflection. In figure, it is shown by angle R. Let us understand these terms by performing the following activity. Activity 1. To understand the incident and reflected ray. This activity requires a white sheet of paper, a strip of black paper, a drawing board or a table, a comb, a torch and a mirror. Procedure. Let us proceed as per the following steps. First, fix the white sheet of paper on the drawing board or a table. Second, close all the openings of the comb except one in the middle by using the strip of black paper. Third, hold the comb perpendicular to the sheet of the paper. Fourth, throw light from the torch through the opening of the comb from one side. With slight adjustment on the torch and the comb, you will see a ray of light along the paper on the other side of the comb. Keep the comb and the torch steady. Place a strip of plain mirror in the path of the light ray. Observation: if after striking the mirror, the ray of light is reflected in another direction. Conclusion: the light ray which strikes any surface is called the incident ray. The ray that comes back from the surface after reflection is known as reflected ray. In the image, you can say the arrangement for showing reflection. Activity 2. To understand the point of incidence, normal, angle of incidence and angle of reflection. In the above activity, draw lines showing the position of the plane mirror, the incident ray and the reflected ray on the paper with the help of your friends. Remove the mirrors and the comb. Draw a line making an angle of 90 degrees to the line representing the mirror at the point where the incident ray strikes the mirror. Conclusion: this line is known as the normal to the reflecting surface at that point. The angle between the normal and the incident ray is called angle of incidence I. The angle between the normal and the reflected ray is known as the angle of reflection R. Look at this picture. Arrangement of showing reflection. Laws of reflection. There are two laws of reflection which are stated as follows. Number 1. Angle of incidence is always equal to the angle of reflection. That means angle I is equals to angle R. Angle of incidence, angle of reflection and the normal at point of incidence all lie in the same plane. Special cases: the incident ray is normal to the plane of the mirror, then the reflected ray coincides with the incident ray, that is, it retraces its path. If the angle of incidence is 45 degree, then the angle between the incident and the refracted ray will be 90 degree. Activity 3. Verification of the first law of reflection to show that angle of incidence is equal to the angle of reflection. Perform the activity given in the activity 2 again and measure the angle of incidence and angle of reflection. Repeat the activity several times by changing the angle of incidence. Enter the data in the table 16.1. Serial number, angle of incidence, angle of reflection. Observation: if the experiment is carried out carefully, it is seen that the angle of incidence is always equal to the angle of reflection. Conclusion: thus, the first law of reflection is verified. Activity 4. Verification of the second law of reflection to show that the angle of incidence, angle of reflection and the normal at the point of incidence all lie in the same plane. Perform activity 3 again. This time use a sheet of stiff paper or a chart paper. Let the sheet project a little beyond the edge of the table. Cut the projecting portion of the sheet in the middle. Look at the reflected ray. Make sure that the reflected ray extends to the projected portion of the paper. Bend that part of the projected portion on which the reflected ray falls. Can you still see the reflected ray? Bring the paper back to the original position. Can you see the reflected ray again? What do you infer? Look at this image. Incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. When the whole sheet of paper is spread on the table, it represents one plane. The incident ray, the normal at the point of incidence and the reflected ray are all in the same plane. When you bend the paper, you create a plane different from the plane which the incident ray and the normal lie. Then you do not see the reflected ray. What does it indicate? It indicates that the incident ray, the normal at a point of incidence and the reflected ray all lie in the same plane. This is another law of reflection. Regular and irregular reflection. If a beam of parallel rays falls on a smooth, well-polished surface, example a plane mirror, then the reflected rays are also parallel to each other. When these reflected parallel rays are received by the eye, they produce a glare. This kind of reflection is known as regular or specular reflection. Look at this mirror. This is regular reflection. A reflecting surface such as a wall is not smooth. It contains a large number of irregularities. When a beam of parallel rays fall on such a rough surface, the reflected rays are not parallel to each other. This is because due to irregularities on the surface, each incident ray will have a different angle or incidence. This will cause each ray of light to be reflected at a different angle. Thus, the reflected rays are scattered in different direction. This kind of reflection is known as irregular or diffused reflection. You can see in this image irregular reflection. It is the irregular or diffused reflection that enables us to see objects without a glare. It must be noted here that the laws of reflection are followed in all kinds of reflection. Formation of image by a plane mirror. Perform the following activity to understand the image formation by a plane mirror. Activity 5. Formation of an image by a plane mirror. A source of light O is placed in front of a plane mirror PQ. Two rays OA and OC are incident on it. Can you find out the direction of the reflected rays? Draw normal to the surface of the mirror PO at the point A and C. Then draw the reflected ray at the points A and C. How would you draw these rays? Call the reflected rays AB and CD. A source of light O is placed in front of a plane mirror PQ. Two rays OA and OC are incident on it. Can you find out the direction of the reflected rays? Draw normal to the surface of the mirror PQ at a point A and C. Then draw the reflected rays at the points A and C. How would you draw these rays? Call the reflected rays AB and CD respectively. Extend them further. Do they meet? Extend them backwards. Do they meet now? If they meet, mark this point as I. For a viewer's eye, add E. Figure 6.8. Do the reflected rays appear to come from point I? Since the reflected rays do not actually meet at I but only appears to do so, we say that a virtual image of the point O is formed at I. As you have learnt already in class 7th, such an image cannot be obtained on a screen. Let's see this mirror. Image formation in a plane mirror. You may recall that in an image formed by a mirror, the left of the object appears on the right and the right appears on the left. This is known as lateral inversion. Now, let's see the characteristic of the image formed by a plane mirror. Mirror. Recall the characteristic of image formed by a plane mirror which you have studied in class 7. Virtual. Image formed by a plane mirror is always virtual because it cannot be obtained on a screen. Erect. Image formed by a plane mirror is always erect, that is upright. Of same size. It is always of the same size as that of object. At same distance. It is always of the same distance behind the mirror as the distance of the object in front of mirror. Laterally inverted. Image formed by a plane mirror is always laterally inverted as the sides of the object gets inverted in the image. Left side of the object seems right and right side of the object seems left in the image. Thus, image formed by the plane mirror is virtual, erect, of the same size as that of object, at the same distance behind the mirror and laterally inverted to the object. Multiple reflections. Reflected light can be reflected again. We visit a barber shop regularly for a haircut. After cutting the hair, the barber places a mirror behind our head to show the reflection of the haircut on the back of our head. The reflection of the hair on the back of our hair is reflected. Again in the reflected kept in front of us. This shows that the reflected light gets reflected again. We can also see that many images for the image on the back mirror are formed on the front mirror. The phenomena of a ray of light being reflected more than once is called multiple reflections. The number of images formed depends on angles between the two mirrors. If mirrors make an angle Q between them and the object is placed in between the two mirrors and the number of images is n, then n is equals to 360 degree divided by theta is equals to 1. If theta is equals to 0 degree, the number of images n is equals to 360 degree divided by theta minus 1, which is equals to infinite. If theta is 90 degree, the number of images n is equals to 360 degree by 90 degree, which is minus 1, which is equals to 3. Periscope. Periscopes are used in submarines to get the image of the outer world or inside the submarines. A periscope is made on the principle of multiple reflection. We can learn to make it by doing the following activity. Activity 6. It requires a long cardboard box and two rectangular mirrors of medium size as shown in the figure. Cut slits at 45 degree angles at both the ends of the cardboard box. Insert the mirror strip through each slit in such a way that their reflecting surfaces remain face to face. Cut holes opposite to the reflecting surface of each mirror. Now the periscope is ready to use. Now let's talk about multiple images. Multiple images. We know that a plane mirror forms only a single image of an object. If we use more than one mirror, multiple images is formed. The number of images n formed by the mirror kept at theta angle with each other is given by n is equals to 360 degree by theta is equals to 1. Let us perform the following activity to form the multiple images. Activity 7. Images formed by the two plane mirrors kept at different angle to each other. Take two plane mirrors, set them at right angles to each other with their edges touching. To hinge them, you can use adhesive tapes. Place a coin in between the mirrors. How many images of the coin do you see? Now, hinge the mirrors using the adhesive tape at different angle. Say 45 degree, 60 degree, 120 degree, 180 degree, etc. Place some object, say a candle, in between them. Note down the number of images of the object in each case. Finally, set the two mirrors parallel to each other. Find out how many images of a candle placed between them are formed. Kaleidoscope. A kaleidoscope is a tube of mirror containing loose colored objects such as glass pieces or beads. The light enters from the end containing the colored objects and gets reflected. This light is further reflected multiple times by the mirrors inside the tube and finally enters eye placed at the other end of the tube. As the mirrors are hinged, multiple images of an object are created. The combination of these multiple images form a variety of patterns. Let us make a kaleidoscope with the help of the first activity given on the next page. Activity 8. Aim to make a kaleidoscope. Activity to be performed under the adult supervision. Things required: 3 plane mirror, steps of dimension, 3 plane mirror strips of dimension 15 into 6 cm, chart paper, glass plate, colored glass pieces and beads. Method: join the 3 mirror strips to form a prism. The reflecting surface of the mirror should face each other. Make a cylindrical tube from a thick chart paper. Make a circular cardboard disc with a small hole in the middle. Close one end of the tube with the circular disc. From the other end, slowly slide the mirror prism inside the tube. Place a plain, transparent glass plate on the top of the prism from open end of the tube. Put small pieces of colored glass or colored beads on the glass plate and close this end of the tube with a ground glass or a translucent sheet. Ensure that there is enough spaces for the colored pieces to move around. The kaleidoscope is ready now. Test the kaleidoscope by peeping inside through the hole. Look at this picture. Making of kaleidoscope. Observation. When you look through the opening in the kaleidoscope, you will see different kinds of pattern in it. Slowly rotate the tube and you will see the changing colors and patterns every time you rotate the tube. You will see different kinds of patterns in it. This happens because of the placement of mirrors. Numerous images are formed due to the way in which the glass pieces and the beads arrange themselves. Now let's see what is dispersion of light. When white light passes through a glass prism, it splits into 7 colors: violet, indigo, blue, green, yellow, orange and red. That is Vibgyor. This phenomenon is called dispersion. This phenomenon of splitting of light into 7 colors, violet, indigo, blue, green, yellow, orange and red, is known as dispersion of light. Dispersion was first observed by Sir Isaac Newton when he passed white light through a glass prism. We can recall the activity performed in the class 7. Here is another activity, activity 9, showing that sunlight splits into 7 colors. Causes of dispersion. Cause of dispersion is that a transparent medium like a glass prism bends or deviates different colors of light by different amounts. The deviation is maximum for violet and minimum for red. When white light passes through a prism, its constituent light having different colors deviates by different angles and hence we get the spectrum of 7 colors. Activity 9. To show the dispersion of light, place a plain mirror of suitable size it in a bowl as shown. Fill the bowl with water. Put this arrangement near a window such that direct sunlight also falls on the mirror. Adjust the position of the bowl such that the reflected light from the mirror falls on the wall. If the wall is not white, fix a sheet of white paper on it. Reflected light will be seen to have many colors. In fact, the mirror and the water form a prism and breaks up the light falling on them into its constituent colors. Look at this picture, dispersion of light. That is, dispersion of light takes place. Rainbow is a natural phenomenon showing dispersion. We have already learnt about the rainbow in previous class. Students, now let's talk about structure of our eyes. Structure of eyes. Eye is one of the most important sense organs which enable us to see things around us. Visibility of objects become possible when light coming from an object either by emission or reflection enters our eyes. It is therefore important to understand the structure and working of eyes. The eye has a roughly spherical shape. Outer coat of eye is white. It is tough so that it can protect the interior of eye from accidents. It is transparent from the part is called cornea. Behind the cornea, we find a dark muscular structure called iris. In the iris, there is small opening called the pupil. The size of the pupil controlled by the iris. The iris is the part of that eye which give it its distinctive color. When we say that a person has green eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. Let us see how. Let's check this image. This is the image of human eye. Blind spot. At the junction of the optic nerve and the retina, there are non-sensory cells. So, no vision is possible to that spot. This is called the blind spot. Its existence can be demonstrated as follows. Activity 10. Make a round mark and cross on a sheet of paper. With the spot to the right of the cross, make a round mark and cross on a sheet of a paper with the spot to the right of the cross. The distance between two marks may be 6 to 8 cm. Hold the sheet of the paper at arm's length from the eye. Close your left eye Look continuously at the cross. Move the sheet slowly towards you, keeping your eye on the cross. What do you find? Does the round mark disappear at some point? Now close your right eye, look at the round mark now and repeat the activity. Does the cross disappear? The disappearance of the cross or the round mark shows that there is a point on the retina which cannot send messages to the brain when the light falls on it. Look at this image, demonstration of blind spot. The impression of an image does not vanish immediately from the retina. It persists there for about 1/16th of the second. So if still images of moving objects are flashed on the eye at a rate faster than 16 per second, then eye perceives the object as moving. The movies that we see are actually a number of separate pictures in proper sequence. They are made to move across the eye usually at a rate of 24 pictures per second, faster than 16 per second. So we see a moving picture. The movies that we see are actually a number of separate pictures in proper sequence. They are made to move across the eye usually at a rate of 24 pictures per second, faster than 16 per second, so we can see a moving picture. Normal vision. Nature has provided eyes with eyelids to protect from any object entering the eye. Eyelids also shut out light when not required. Eye is such a wonderful instrument that it can see distant objects as well the near objects. Clearly, the minimum distance at which the eye can see objects distinctly varies with age. The most comfortable distance at which one can read with normal eye is about 25 centimeter. Myopia or short-sightedness. Some persons can see near objects clearly but cannot see distant objects so clearly. This defect is known as myopia or short-sightedness. Myopia can be corrected by using a spectacle made from the concave lens of suitable focal length. Hypermetropia or long-sightedness. Some person cannot see near objects clearly but they can see distant objects quite well. This defect is known as hypermetropia or long-sightedness. Hypermetropia can be corrected by using a spectacle made from convex lens of suitable focal length. Cataract. Sometimes, particularly in old age, eyesight becomes foggy. It is due to the eye lens becoming cloudy. When this happens, persons are said to have cataract. This is a loss of vision. Sometimes extremely severe, it is possible to treat this defect. The opaque lens is removed and the new artificial lens is inserted. Modern technology has made the procedure simpler and safer. Care of eyes. It is necessary that you take proper care of your eyes. If there is any problem, go to eye specialist, have a regular checkup. Do not look at the sun or powerful light directly. Too little or too much light is bad for eyes. Insufficient light causes eye strain and headaches. Too much light like that of sun and powerful lamp or laser torch can injure the retina. If advised, use suitable spectacles. Always read at normal distance. For vision, do not read by bringing your book too close to your eyes or keep it too far. Wash your eyes frequently with clean water. Never rub your eyes. If particles of dust go into your eyes, wash your eyes with clean water. If there is no improvement, go to doctor. Do you know? Nocturnal animals have eyes which collect maximum portion of dim light. In owls, there is a huge retina to do so. Many animals have a special reflecting membrane behind the retina which reflects the light rays that have missing hurting a red cell. This membrane is responsible for the glow you see in an animal's eye and when light shines on it. Visually challenged persons can read and write. Some persons, including children, can be visually handicapped. They have very limited vision to see things. Some persons cannot see at all since birth. Some persons may lose their eyesight because of a disease. Some persons try to identify things by touching and listening to voices more carefully. They develop their other senses more sharply. However, additional resources can enable them to develop their capabilities further. Now let's talk about Braille system. What is Braille system? The most popular resource for visually challenged persons is known as Braille. The present system was adopted in 1932. There is Braille code for common languages, mathematics, and scientific notation. Many Indian languages can be read using this Braille system. This is the image of Louis Braille. Louis Braille, himself a visually challenged person, developed a system for visually challenged persons and published in 1821. Braille system has 63 dot patterns or characters. Each character represents a letter, a combination of letter, a common word, or a grammatical sign. Dots are arranged in cells of 2 vertical rows of 3 dots each. Look at this image. These are the examples of dot patterns used in Braille system. Patterns of dots to represent some English alphabets and some common words are shown below. These patterns, when embossed on Braille sheets, help visually challenged to recognize words by touching. To make them easier to touch, the dots are raised slightly. Visually challenged people learn the Braille system by beginning with letters, then special characters and letters combination. Methods depend upon recognition by touching. Each character has to be memorized. Braille text can be produced by hand or by machine. Typewriter like devices and printing machines have now been developed. Some visually challenged Indians have great achievements to their credit. Divakar, a child prodigy, has given amazing performances as a singer. Many visually challenged persons have great achievements in their credit. Let us know about them. Mr. Ravindra Jain, born complete visually challenged, obtained his Sangeet Prabhakar degree from Allahabad. He has shown his excellence as a lyricist, singer and music composer. Mr. Lal Advani, himself visually challenged, established an association for special education and rehabilitation of disabled in India. Besides, he represented India on Braille problems to UNESCO. Helen Keller, an American author and lecturer, is perhaps the most well-known, inspiring visually challenged person. She lost her sight when she was only 18 months old. But because of her resolve and courage, she could complete her graduation from a university. She wrote a number of books, including The Story of My Life in 1903. Based on the above chapter, let's do check and mate. Write true and false for the following statements by your own understanding. Now let's summarize the chapter in a nutshell. First, light which falls on the surface of reflective material is known as incident ray. Light which turns back in the same medium after reflection is called reflected ray. The point at which the light ray strikes the reflecting surface is called point of incidence. The perpendicular line drawn from the point of incidence on the reflecting surface is called normal. The angle formed between the incident ray and normal is the angle of incidence. The angle formed between the reflected ray and the normal is the angle of reflection. Two laws of reflection are: the angle of incidence is equal to the angle of reflection. Incident ray, reflected ray and the normal drawn at a point of incidence to the reflecting surface lie in the same plane. Light is reflected from all surfaces. Regular reflection takes place when light is incident on smooth, polished and regular surfaces. Diffused irregular reflection takes place from rough surfaces. Images formed in a plane mirror undergo lateral inversion. Two mirrors inclined to each other give multiple image. Periscopes are used in submarines, tanks and also by soldiers in bunkers to see things outside. Now let's see some keywords which came in the chapter. Incident rays, ray falling on the surface of a reflecting material. Reflected ray, rays that turn back after in the same medium after reflection. Point of incidence, point on the reflecting material where rays strike. Normal, perpendicular line drawn from the point of incidence. Angle of incidence, angle formed between the incident ray and normal. Angle of reflection, angle formed between the reflected ray and the normal. Laws of reflection, incident angle is equals to reflected angle, and incidence angle, reflected angle and normal are all in same plane. Regular reflection, reflection from a smooth surface. Periscope, an instrument made by placing two mirrors in a pipe. Kaleidoscope, an instrument to make beautiful images by arranging mirrors. Dispersion, splitting of white light into 7 colors after passing through prism. Iris, a dark muscular round part behind the cornea. Pupil, a small opening in the iris. Retina, a layer on the back of the eye where image is formed. Normal vision, distance on which a thing is clear to a person to see. Myopia, see short-sighted object clearly, also known as short-sightedness. Hypermetropia, long-sightedness or to see distant objects clearly. Thank you, students. Now we will meet in the next class.